Hello guys, my name is Engineer Halidi. We want to solve problem on the complex number. So I say evaluate what? 1 plus I all raised by 1 raised by 1 over 5. That is the fifth root of this particular complex number. Now what we want to do now simply is just to convert this one to a polar form. Since we are looking for the fifth root, then we use the Moivre's theorem. Now what we do is that let's say z equal to 1 plus I. Now, so what we want to do now is to look for polar form of this. So absolute of z is equal to square root of, don't forget, so it's likely to what? S plus iy. So we look for s square plus y square. And that will give us what? 1 square plus 1 square. Because the coefficient of I is your y. This is the imaginary part, which will now give us what? Square root of 2. Then after that, you look for what? Your argument, which is the argument, which is angle, which is an inverse of what? Y over x. And that, how do we go for that? Tan inverse of what? What is y? 1. The coefficient of I, x is 1, which is a real part. So we're going to have tan inverse of 1 is equal to 45. And 45 is equal to what? Pi over 4. Don't forget that pi is equal to 180. So 180 divided by 4 will give us what? 45. So since we have solved that, which is the argument in radian, then we can now combine them and say the absolute of r of z, or let's say r into bracket cos theta plus I sine theta is the polar form of what? Of z. So what do we have? We are going to have it as what? Z equal to what? Root 2 all what? Open bracket cos what? Theta is what? Pi over 4 plus I sine pi over 4. So we'll close the bracket. Now this is the polar form. But what we are looking for is what? Z is by what? 1 over 5. How do you do that? Because if z replaces 1 now, everything becomes z is 1 over 5. So we are looking for what? Square root of what? Cos what? Square root of 2 open bracket cos what? Pi over 4 plus I sine what? Pi over 4 all raised by what? 1 over 5. So what I want to do now is to what? Simply take square root of what? All raised by what? Then that means if you apply, well, this one will affect this. So remember that a raised by m or bracket n is equal to a raised by m times n. So what I want to have now is cos pi over 4. Now for us to bring this one onward in, we are going to first of all add 2 pi k, then divide all through by 5. To bring this one in, why are you adding into 2 pi k? To get all possible values of what? The fifth root of what? Of k of this particular value. It will start from where? K equal to 0, to 1, to 2, to 3, to 4. 1, 2, 3, 4, 5. So k can take any of these values that will give us the fifth root. Then plus what? What? I sine what? Pi over 4 plus 2 pi k all over 5. All bracket. Now, when you do that now, what we're going to have now is that the LCM of this one is 4. So we're going to have root of 2 all bracket 1 over 5 cos. This one will give us pi plus this one, if we add it with what? With that, we can have it as what? 8 pi over k all over what? 20. Find the LCM, then divide it by 20, by 5. So the LCM of this side is 4. 4 divided by 4 is 1. 1 times is pi plus what? 4 divided by what? 1 is what? 4 times is 8 pi k. So then if you add 4 times 1 over 5, that's what I'm saying, plus I sine what? Pi, the LCM is 4. 4 divided by 1 is 4, is 1. 4 divided by 4 is 1 times pi is pi. Then plus 4 divided by 1 is what? Is 4. Then times that one we have 8 pi k times 1 over 5. So we can write it that way. So final answer of that was square root of what? 1 over 5 cos what? Pi plus 8 pi k all over 4 all over 20 plus I sine what? Pi plus 8 pi k all over 20. So this one will be your answer for that what? 0 raised by 1 over 5. So it now depends on what? Don't forget your k. Take a value of 0, 1, 2, 3, 4. Because it's 50 we are looking for. So it depends on how they arrange the answer. It all depends on how they arrange the answer. If they leave the answer like this, fine. They leave it like this, fine. They can even, you can use the value one after the other by putting what? K equal to 0, k equal to 1, k equal to 2. If you do that, you'll be having 5 different answers. You understand? For that particular value. But most of the times, for objective case, they don't do it like that. They will just leave the answer like this. They will not put all this condition for k inside. So in that case, you cannot even use calculator to solve it. That means your answer will be in form of k functions. So in that case, you can have the first answer can be when k equal to 0, then you would have root 2 raised by 1 over 5. Open bracket. If you put 0 here, you would have what? Pi over 20. 5 over 20 plus what? I sine what? Pi over 20. That's what I want to have. The first one. When k equal to 2, equal to 1, you would have what? Then 1 will not be 1 here, now be 9 pi over 20 plus I sine what? Sorry. Oh, you're supposed to put cos here, sorry. Cos pi over 20 plus I. This one will be cos 9 pi over 20 plus I sine 9 pi over 20. To get the second one, the third one now is what? The root. One of the answer is what? 2 raised by 1 over 5 with 2 raised by 1 over 5 cos what? Put 2 here, we have 16 pi plus what? 17 pi over 20 plus I sine what? 17 pi over 20. This one will not be one of our answer. The third one, the fourth one, when k equal to 3, what? Cos what? 3 here is 24 plus pi is 25 pi over what? 20 plus I sine what? 25 pi over 20. So the last one, k equal to 4, will now be a square root of what? This is 1 over 5. 1 over 5. Square root of square root of the 2 over raised by 1 over 5 equals to what? Open bracket cos 4 here we are going to have it what? 8 times 4 is 32 pi plus 1 is 33 over 20 plus I sine what? 33 pi over 20. So these are the possible values 1, 2, 3, 4, 5. Give us the possible values of k. Now, if they ask you in the exam, maybe they now ask you which of the answer is the principal root. Principal root of the what? The value that we solve I plus 1 plus I all raised by what? 1 over 5 of this one. The principal root will now be what? This. When k will be equal to what? 0. That will give us the principal root, which is what? 180 divided by 20. Their value will be so small that it will be closer to positive what? X value. Because this is our agar diagram drawn from here. So that means that there is I, Y, there is X. So the angle that will be closer to 0 is pi over 20. That will be closer to this. If you press pi over 20, which is 180 divided by 20 now, you see that the value will be so big that you have, it's so small that you have 9. It's a 9 degree. 9 degree is closer to the value. 9 degree. If you check other ones like this one now, if you press your calculator, times 9 will give us 81. This one times 17 will give us 9 times 17. 17 times 9 will be given us 153. Then this one will give us 25 times 9. You see that it will be getting big. Let me even do 25 times 9. So this one, pi over 20 will give us 9 times, will give us 9 times 33 will give us 225. Then if you do the last one, 33 times what? Pi, which is 180, divided by 20. You see that it gives us 297. It's not as close as this one. So that means this angle particularly is closer to the positive x-axis. The last one is what? If you draw it, the last one now from the beginning is 297. 297 is not closer to 360 degree. If you check the difference from here, check other one. This one will give us 81. 81 is far from it. 81 degree. Press this one, you are going to be having something higher. So the closest angle to the what? To the x-axis is what we call the principal root. So this one will be your principal what? Root. Most likely, principal root always occur at k equal to 0 for a particular complex number. I believe you enjoyed this class. Ensure you subscribe and click the notification button. Thank you.